Hi students, in this lecture I am going to discuss ammeter and voltmeter. Let us see the diagrams for them. So this is what we call galvanometer. You can see here symbol G. G stands for galvanometer. It is mainly used to know presence of current. That means in the circuit, if current is there, it deflects either left or right. You can see here pointer which rotates because of a torque produced by magnetic field that is inside. So when this pointer rotates either left or right, that indicates presence of current. So this is mainly used just to know presence of the current, not to measure values. And you can see next one here. This is, you can see here notation A. A stands for this ammeter, and this is used to measure current. Here you can see MA. This stands for milliammeter. And if you see diagram, this is from 0 to up to 50. That means for this device, maximum range is 50 milliampere. So it can measure maximum 50 milliampere. This is known as ammeter. This is actually milliammeter, okay? And see next one, here you can see MV, millivolts. This is known as voltmeter. It measures potential difference between 2 points. In this we can say 0 to up to 100. So for this device, maximum range is 100 millivolt. So by using this, we can measure potential difference maximum 100 millivolt. Okay. In fact, these three are same devices, means working wise, all are same. Only change is the purpose we are using. Okay. Let us see now the basics of this, how to use them. Let us make a simple circuit. Take a battery, and this is internal resistance of battery. Suppose this is 6 volt and its resistance is 1 ohm. Connect to one load resistor, its value 2 ohm. So in this we can calculate current directly, that is I equal to 6 by 1 plus 2. It is now 2 ampere. So current in the circuit is 2 ampere. Now we want to measure this by using a device, that is ammeter. So we can place that in the circuit in series. Suppose I'm placing here, this is ammeter connecting in the circuit. So we can connect this in series anywhere in the circuit, because throughout the circuit current is the same. You can see here, it is everywhere 2 amperes only. Therefore, we can connect this in series with the circuit anywhere. Okay. And here one more key point is, this is having some resistance. So since it is having resistance, current will change. That means now current becomes I dash equal to 6 upon 1 plus 2, that is 3, plus resistance of ammeter. That means now current will be less than 2 ampere. Therefore, this will measure a current which is less than 2 ampere. So if you want to measure exact value, its resistance must be small, or you can say its resistance must be equal to 0. So if the device is having 0 resistance, it can measure exact current. but practically it is not possible. It will have some resistance. Therefore, its resistance must be as small as possible. So less resistance means it is more accurate. So condition is for ideal ammeter, resistance is 0. Okay. And we are connecting this in circuit, it is in series. Okay. Right. Let us do one thing. We want to measure now potential difference across 2 ohm resistor. Between these 2 points, we want to find the potential difference. So we connect here one device, that is voltmeter. So we are connecting now this one parallel to that resistor. Okay. So we want to find out potential difference between these two. Now see carefully. When 2 ampere current flows like this, 2 ampere, if you assume that no current passing through this voltmeter, no current passing, entire current passes only through 2 ohm resistor, then potential difference across that resistor is current is 2 ampere, resistance is 2, therefore potential difference will be 4 volt. That means this device has to measure a potential difference of 4 volt. Okay, this is possible if no current is passing through the device, and that is possible only if this device is having infinite resistance. But practically, infinite resistance is not possible. So condition is that voltmeter must have very high resistance. The more is the resistance, the more accurately it measures a potential difference. Okay. The reason is that for its working, it requires, means for deflection, it requires current. So there must flow, some current flow must be there in this for its working. That's why reading given by the voltmeter will be less than the actual value. Okay. So what we are saying is for ideal voltmeter, resistance is infinity. And how to connect means we have to connect parallel to the circuit. So for ammeter, resistance must be very small. For voltmeter, resistance must be very high. Connecting ammeter in series, connecting voltmeter in parallel. Okay. So these are the some basic points regarding ammeter and voltmeter, right? Let us see now how to convert a given galvanometer into ammeter. So first thing, ammeter is a device used to measure current. Its resistance is very low. For ideal ammeter, resistance is 0. A galvanometer is converted into an ammeter by connecting a suitable small resistance, calling as shunt resistance, parallel to it. And ammeter is connected in series in the circuit. Let us see once. Already we have discussed the first point. Second point already we discussed. Fourth point also we have discussed. Now we have to focus third point. Okay. See now. So we are taking a galvanometer. So we want to convert this. I am taking symbol as G for galvanometer. We want to convert this into ammeter. And we are knowing that ammeter should have very small resistance. So we are connecting here one small resistance parallel to galvanometer. This is what we call shunt resistance. See advantage of connecting parallel. So we have learned that in parallel combination, effective resistance is less than the least value. So if you take here small value in parallel combination, effective value will be smaller than this shunt resistance. That means for this entire combination, now resistance will be very small. Okay. And this entire one we are calling as now ammeter. This entire one we call it as ammeter. And this we are placing in series in the circuit. I am repeating. This entire one is called now ammeter. We place this in circuit in series combination. Let us see how to find resistance of the shunt. Assume that I current is a flowing. Assume I current flows in circuit. After reaching this junction, current divides into the shunt resistance Is into galvanometer. I am taking this as I suffix G. I am taking this is a current for which deflection of the galvanometer is maximum. I am repeating this I suffix G, current through galvanometer for which deflection will be maximum. That means this is a maximum current that can be measured by galvanometer. Okay. So here one more advantage of connecting small resistance parallel to galvanometer is most of the current passes through shunt resistance. So only small current passes through the galvanometer. That means this is now protected from the flow of high current, because if a high current flows, it will be damaged. So we can protect it by adding small resistance parallel to it. Okay. Now see carefully. Since these two are parallel, what we can say is across these two potential difference is same. So I can write Ig into G. I am taking capital G for resistance of galvanometer, that notation. Potential difference across that is also equal to potential difference across a shunt. I'm taking S for shunt resistance. Okay. Now in the place of S, I'm taking I minus Ig into S. See from this, what is S value? S equal to G upon, it is I by Ig minus 1. And I'm taking I by Ig as N. It is now G by N minus 1. So here N stands for, before connecting shunt, it was able to measure only Ig value, maximum current. After connecting shunt resistance, we can measure maximum value, that is I. So here Ig divides into this, remaining is Is. Total value is now I. So this entire device can measure maximum I. Therefore, I by Ig gives how many times its maximum capacity has increased. Okay, that is N. So G by N minus 1. So using this result frequently, otherwise directly what we can do is always equate across the galvanometer and across a shunt. Potential difference must be same using this result. Okay, that is a relation between shunt resistance and resistance of the galvanometer. And here you can see one more point, I by Ig. If you observe, if N is more, S will be less. N value more means we can measure more current. That means the less is the shunt resistance, the more range it can measure currents. So if we want to measure very high currents, shunt resistance must be very low, right? Means low shunt resistance means it can measure high range currents. Okay. That is about the third point. Let us see next one. conversion of galvanometer into voltmeter. So it is a device used to measure, sorry, it is used to measure potential difference, not current. Its resistance is very high. For ideal voltmeter, resistance is infinity. Third point, okay, we will discuss now. Coming to fourth point, it is connected in parallel in the circuit. And see third point, a galvanometer is converted into voltmeter by connecting a suitable high resistance in series to it. Let us see once. So we have seen that a galvanometer can measure only small currents. So when it measures a small currents, then corresponding potential difference, I'm taking as V suffix G. This is maximum potential difference that can be measured by galvanometer, that is equal to current into its resistance. Resistance is G. Okay, this is a maximum potential difference that can be measured. Now, if we connect a high resistance, take it as R. Now this entire one we call it as voltmeter. See here what we are doing. We are increasing now resistance. When resistance is increased without changing current, we can increase now potential difference. So now potential difference which we can measure is G plus R, that is now resistance, into Ig. Okay, that means now we have increased its range by adding high resistance. Okay, we can get same kind of relation like S equal to G by N minus 1. We get condition here. See, I am taking ratio here, or I can say in the place of Ig, writing Vg by G. Okay, then this becomes V by Vg is equal to G plus R by G. Okay, and I'm taking this as N, means its range has become N times, means it is able to measure now N times the potential difference that was measured earlier. Okay, so from this what I can write, R equal to G into N minus 1. So if we want to increase the range, let us say 100 times, then N becomes 100 minus 199. So how much resistance we have to add to increase its range by 100 times? It is 99G. If you want to increase 1000 times, 1000 minus 1. So 999 into G. That is the resistance we have to add. Okay, it is a very simple one. Let us solve questions to get more clarity. Let's see, first one. An ammeter is to be constructed which can read currents up to 2 ampere if the coil has resistance of 25 ohm. This is capital G, and takes 1 milliampere per full scale deflection. This is I suffix G. Okay. What should be the resistance of the shunt used? What should be the resistance of the shunt used? So we have to convert the range from where to where? From 1 milliampere to 2 ampere. That means we have to increase by how many times? 2 by 1 milliampere, 2000, right? G value 25. So G value 25. So I'm taking directly S equal to G by N minus 1. G value 25 ohm. Ig for full scale deflection current required 1 milliampere. We want to measure 2 ampere. That means S equal to 25 upon, this is now, see how much? This is now 2 by 1 milli, that is 2000, right? Minus 1. So when compared to 2000, 1 is very small. So approximately 25 by 2000. Okay. That is the resistance that we have to add parallel to galvanometer. Okay. So this question is taken from HC Verma. And see next one. And this question also taken from HC Verma. See question given. A voltmeter consists of a 25 ohm coil connected in series with a 575 ohm resistor. That means total value how much? 600, right? Connecting in series. Total value 600. The coil takes 10 milliampere per full scale deflection. This is now I suffix G. What maximum potential difference can be measured on this voltmeter? So 25, 575. This is now 10 milliampere. Now see what is that value given. G value 25 ohm, R value 575 ohm, both are in series. For full scale deflection, current is given 10 milliampere, right? So what maximum potential difference we can measure? So we can write V equal to I into R. So I suffix G into R plus G. Okay. This is a 10 milli, 10 power minus 3. R plus G, it is now 600. So it is equal to how much? 6 volt. So we can measure maximum 6 volt. Before it was connected, its range was, we can see here, V suffix G. That is equal to 25 into 10 milliampere. So this was a maximum potential difference before this was connected. After connecting this, now we are able to measure up to 6 volt, right? See the next one. So this is a previous article question asked in 1991 for 2 marks. A micro ammeter has resistance of 1000, having resistance of 1000 and full scale deflection, full scale range, it is a 50 microampere. Micro means 10 power minus 6, right? It can be used. It can be used as a voltmeter or as a high range ammeter provided a resistance is added. Provided a resistance is added to it. Pick the range and resistance combinations. So we have to focus now the resistance combinations which are possible, right? Now see once how to solve. So first of all, write down the given data. First, I'm writing here. Given data is has a resistance of 100. I'm taking this as G value 100, resistance 100, and its range 50 microampere, full scale range 50 microampere. So next it is going we have to convert, right? See, first option, range 50 volt and resistance. See the first option, option A. So we want 50 volt range. And how much we have to connect? 10 kilo ohm. Let us cross check. Is it right or wrong? So directly what we can do here, V equal to, so 50 equal to, current is a 50 micro 10 power minus 6 into, here what I can do, R plus G. R value we have to find out, right? Or check this one, R value 10 kilo. 10 kilo means 10 into 10 power 3, 10 power 4 plus 100. So I think this we can neglect. Okay. When compared to 10 power 4, remaining is now. Check it once, is it matching or not? So 10 power 4 and here one more 1 0, 10 power 5, 10 power 5. Remaining is out here 10 power minus 6. So it is now 50 into 10 power, sorry, 5 into, this is 1 0 5, remaining is 10 power minus 1. Therefore it is now 5 10 power minus 1. So first option is not correct. Okay, it is not matching. Second option, so we have to connect a 10 volt range. We want 10 volt range. And how much is to be connected? 200 kilo ohm in series. Let us cross check this. So V equal to I value 50 micro. So 50 10 power minus 6 R plus G. Again, when compared to this, we can neglect now 100. This is now 2 10 power 5, right? Kilo 10 power 3 and 2 zeros 10 power 5. Now see what we can do. 10 power 5 and one more zero here, 10 power 6. Cancel this one. So 5 2 is 10. So option B is correct. Okay. Next, remaining two regarding what you call ammeter. So he expecting option C 5 milliampere, and for that we have to connect now 1 ohm resistance. Cross check once. S equal to G by N minus 1. This is 50 micro and this is now 5 milli, right? That means 5 milli, 5 10 power minus 3, 5 50 micro, 5 10 power minus 5, right? Check it once. 50 10 power minus 6, 0 is there, 10 power minus 5. This becomes how much? It is 100. So 100 minus 1. So approximately 1, right? So option C is correct. Next, option D, 10 milliampere. Okay, 10 milliampere asking here how much? 1 ohm. Let us check. I can say directly here, S equal to 100 by, for 5 milli means 100. So it is now, sorry, this is 10, right? 10 milli. For 10 milli means it becomes 200 minus 1, approximately half, but given 1. So not correct. So correct options are B, C. Okay. Like this, directly we can verify. See next one. A galvanometer gives full scale deflection with 0.006 ampere current. By connecting it to a 4990 ohm resistance, it can be converted into voltmeter of range 0 to 30 volt. If connected to 2N by 249 ohm resistance, it becomes an ammeter of range 1.5. Students, first you have to focus here. Full scale deflection. 1, 2, 3. This is now 6 milliampere, right? By connecting this much resistance, we can convert into a voltmeter of range 30. Let us see once how we solve the problem. First, write down given data, given Ig value 6 milliampere, right? Condition given that by connecting a resistance of 4990 ohm, it is able to measure potential from 0 to 30 volt. Okay. So now what we can do from this given data, I can write 30 equal to V equal to I into R. I value 6 milli. 6 milli into R plus G. R value 4990 R plus G. Right? So we are connecting in series. So this is now resistance of galvanometer. This is now the one which are connecting. So from this what we can say, G value 6 here 5 times. So 5000. 5000 minus 4990. G value 10. So this we have to use in the next condition. The purpose of giving this data is we have to find resistance of the galvanometer. Now see the next one. If connected to a 2N by 249 ohm resistance, it becomes an ammeter range 1.5. See carefully. Ammeter range 1.5. So writing S equal to G by N minus 1. G value we got 10. N value we want to measure 1.5 ampere. I am writing here. N equal to 1.5 by Ig value 6 milli. 10 power minus 3. This becomes how much? 1500 by 6. Check it once. 3 zeros. Right. So this is equal to, I think, 250, right? 250. This is 250. So N value 250. So 250 minus 1, that is a 10 by 249. So we are given here in the place of 10, 2N, right? So this is given as a 2N. This is a 2N means N value. N value is a 5. Okay. So like this, we can solve the problem. So this is a question asked in 2014 advance, right?